Here we go again. This is a fantastic question. Biodiesel production, biodiesel production, trans-esterification. This question is based on not only the trans-esterification, but also some sort of complicated calculations. So let's put our full focus on this question. Okay, there can be a question similar to this in your sac. You never know. All right, let's look at this now. When you look at this question, we know that compound A is a triglyceride. Triglyceride, we are using methanol trans-esterification catalyst. We are going to get three molecules of this is glycerol, obviously. We know that, and this is three molecules of biodiesel. So three biodiesel, which are methyl esters, right? When there's a question like that, what is the first thing you need to know? You need to be able to draw the structure of the biodiesel molecule straight away. That's one of the skills you need to have before you start doing before you get start doing your SACs or the final exams, right? So you need to practice, practice, practice. So let's see how I can help you to do the structure of the biodiesel molecule straight away. Okay. Now, okay, let's try to answer these questions first. To which category of the compound A? You know that triglyceride. Why it is a triglyceride? You know why it is a triglyceride? Because it's a got a triester group, triglyceride, and it got glycerol part as well. So three esters, triglyceride. So you can say it's a lipid. So triglyceride. That's simple, isn't it? Okay. Name the fatty acid associated with A. Now this one is this is interesting. Fatty acid. There are okay. These are the fatty acid parts. You see the fatty acid part. So okay, let me show you how to get the fatty acid part. So this is in order to get the fatty acid part, you need to separate. No, you need to hydrolyze what? Hydrolyze the ester bond. So see the two oxygen. This is separated. You have to make sure the two oxygens are separated. During hydrolysis, what will happen? OH goes here. It goes here. So then you are going to make the fatty acid. What is the fatty acid? Okay, let me show you how to get the fatty acid. It has to be C17, H29, H29, COOH, right? So that's the fatty acid, and both the fatty acids are the same. No, three fatty acids, same three fatty acid here. So you are going to get three biodiesel molecule, same biodiesel molecule. They're the same. I mean, what I was trying to say, you can have different fatty acid. Yeah, what I was trying to say, you can have different fatty acid parts in the triglyceride. In this case, they're the same. They're the same. But you can have different. Okay, that's what I was trying to say, man. Okay. All right. Now listen. What do you think about this fatty acid? You can look at the data booklet and find out what the name of this fatty acid. I mean, other than finding the name of the fatty acid, apparently it is linolenic. Linolenic. Linolenic fatty acid, right? Now, linolenic. Now, is it a saturated or unsaturated? How do you do that? How do you know? Okay, firstly, get the molecular formula of this, which is C8H30O2. Now, you know that if this was to be saturated, this has to have C18H36O2, right? 18 times 2, 36O2. Now, as you can see, there are what? There are 6 hydrogen missing. 6 hydrogens are missing. 6 hydrogens are missing means how many double bonds? How many carbon-carbon double bonds? There are 3 carbon-carbon double bonds in each fatty acid. This is ridiculous. Each fatty acid stop it. Each fatty acid should have what? 3 carbon-to-carbon double bonds. So in this case, in this triglyceride should have 9 carbon to carbon double bond, because each fatty acid part has about 3 times 3 9. All right, name the fatty acid. We've done that. Would the fatty acid be classified as saturated, unsaturated? Explain your answer. It's a 2-mark question. In order to explain the answer, first you need to say there are no, it's polyunsaturated, because polyunsaturated. Uh, why is that? Because there are more than three carbon-carbon double bonds. Yeah, this is due to the fatty acid having more than one. Yeah, so why polymeres? What is such a what they're asking us to what? They're asking us to explain. That's stupid. So what do you have to say? This is polyunsaturated more than, or you can say there are three. We prove it. There are three carbon to carbon double bonds in each fatty acid fatty acid part. Fatty acid no, we can say carbon chain. Carbon chain. It's each carbon chain. This is ridiculous. Carbon chain. Carbon chain, right? That's done. Draw the structure of the compound B. Yo, compound B is glycerol, man. Why do they want us to do glycerol, huh? They want us to do glycerol. It's in the data booklet. Why can't just this ridiculous, man? I don't know why they want us to do glycerol. Try, okay? Highly water soluble, yeah. Explain compound B. Yo, again, even without looking at the question, I knew now it was highly water soluble because what do you need to say? Two or it hydroxyl group. Hydroxyl groups, OH group can make hydrogen bonds with water. Compound with glycerol, which has, you can say three hydrox. What do you have to say? Three hydroxyl group. We have we show that. So we can say uh, you have to say what? Did you say explain why? Draw the structure. We have to say this is glycerol. Glycerol has one which there are three hydroxyl groups. So glycerol, there are three hydroxyl group. This is really annoying, isn't it? There are three hydroxyl groups which can make which produces or which can form which forms hydrogen bonds with water molecules which resulting which can make hydrogen. What am I saying? You can say there are three hydroxyl groups which can form hydrogen bonds with water, which make it more soluble. Simple. Draw the structural formula of one molecule of compound C. Oh, they want us to do what? Oh, what? They want us to do the biodiesel molecule. So I'm so excited to do biodiesel molecule because what? So we got the fatty acid, right? Remember the fatty acid? What is the fatty acid? C17. I'll write the fatty acid C17, H29, isn't it? Get the fatty acid first. COOH. Reacting with what? What is the alcohol? Methanol. It is methanol. Yeah. Methanol. Now I'm going to draw the biodiesel molecule. Oh, that's okay. This is the easy way. No, this is the difficult way of doing that. But let me show you how to do this easy way. So then this is esterification, but you can just do the transesterification as well. Okay, then here OH and H, right? Remember? So I got the fatty acid separated. That's how. So that's the biodiesel molecule plus H2O water. But this is the structure of the biodiesel molecule. You could do that without doing that. Okay. So if you want to do that, if you want to draw the biodiesel molecule straight away, this is what you need to do. Okay. Without hydrolyzing it, just do that. Get the H. See the H here? The alcohol H. You see the alcohol H? Make sure you go send that H with the oxygen of the glycerol part. Yeah? Is that clear? Then you see this and this oxygen here, they get joined. So what I'm saying is, yeah. So these two parts are going to join. So in other words, what I was trying to say, in our biodiesel molecule, this is the red part, and this is the sorry, black part. Okay, you should be able to do that. Okay, it is important that you practice how to draw the biodiesel molecule straight away using transesterification. Now, in this question, I hydrolyze the biodiesel molecule into fatty acid and glycerol separately. Then I reacted each fatty acid in a with the alcohol. You didn't have to do that. You should be able to do this. You should be able to find out the structure of the biodiesel molecule from here. Okay. All right, that's done. Uh, in separate reaction, under suitable condition, compound A will react with hydrogen gas. What mass of hydrogen? Okay, so that's a separate reaction. They are saying you get the triglyceride, then you are reacting the triglyceride with hydrogen. Now it is important to know 1 mole of a triglyceride. Okay, why do you, firstly, wait. Why do you think the triglyceride is going to react with hydrogen? That's the first question you need to ask yourself. Ask yourself why it is reacting. You remember, there are carbon-carbon double bonds in the triglyceride. So hydrogen can undergo hydrogen can undergo addition reaction with carbon-carbon double bond, right? Right. That is why. So so if you have 1 mole of the triglyceride, Trig, how many moles of carbon-carbon double bonds have you got? Every molecule has got what? 3, 9. 1 mole of triglyceride should have. It's ridiculous, man. 1 mole of triglyceride must have 9 moles of carbon to carbon double bonds, because every molecule has got every fatty acid part has got 3 carbon to carbon double bond. So there are 3 fatty acids. What I'm saying is this. So sorry if you didn't. Okay. All right, this part. Okay, let me show it to you. Let me clean this up. Here in this part, no, not that part. This part having 3 carbon to carbon double bonds. 3 here, 3 here, 3 here. That's why 9. So if you have 1 mole of triglyceride, there are 9 moles of carbon to carbon double bonds. If you have 1.5 moles of Trig, there's 9 times 5 carbon to carbon double bonds. Is that clear? No, not 9 times 5. That's so wrong. 9 times 1.5 carbon to carbon double bonds. Is that clear? So which is it's going to be equal to 9 times 1.5? Is that 13? So how many number of moles of carbon-carbon double bonds? You have number of moles of carbon-carbon double bonds is 13.5 moles. 13.5 moles. Yeah. Okay, we worked out the number of moles of carbon-carbon double bonds. Now carbon-carbon double bonds react with 1 mole of hydrogen. Yeah, because you see that? To produce what? Hydrogen going here, hydrogen going here. It's addition reaction. Therefore, we need how many? 1 to 1 is the ratio, isn't it? So this is a good question. Therefore, number of hydrogen you need is going to be equal to 13.5 moles. Then the mass of hydrogen is going to be equal to 13.5 times 2, 27 grams. Oh, I made a mistake, didn't I? I made a mistake. I did not show you how to do that. I just read here. Okay, let me go through this again. What did I do? 1 mole of triglyceride has got 9 moles of carbon-carbon double bond. Why? If you can, so what I'm going to go back and see this part, C17H29 part has got 3 carbon-carbon double bonds, so 3, 6, 9. That is why I said 1 mole of triglyceride having 9 moles of carbon to carbon double bond. Is that clear? So 1.5 moles of triglyceride should be having 13.5 moles of carbon to carbon double bond. Each mole of carbon to carbon double bond reacts with 1 mole of hydrogen. 1 to 1 is the ratio. Therefore, number of moles of hydrogen is 13.5. Therefore, mass of hydrogen you need is 27 grams. 27 grams. So I did not show you that you. Okay, what else didn't I show you? Okay. I think the rest I showed you. Okay, so I think I showed you this fatty acid reacting with methanol to make a esterific biodiesel molecule. I said that you could do it. What? You don't have to hydrolyze it. You should be able to do that. This step, it is trans-esterification. All right, the last part, H. We are going to do last part. Yeah. What is last part? Okay, now listen to me. Okay, what? The use of renewable feedstock is one of the principle of green chemistry. Yes, renewable feedstock is one of the green chemistry principle. Yeah, we know that. By considering the production of alternate fuel in the vehicle. Okay, by considering the production of alternate fuels in the vehicle. Discuss one example with the exception of production of biodiesel demonstrates the principle. Don't know, maybe what? By considering the production of alternate fuels in the vehicles, discuss one example with the exception of the production of biodiesel that are they talking about renewable fuel? I don't understand this version of English. Man, maybe I'm an immigrant man. Maybe this is not immigrant friendly, is it? This question, the way it is worded. Do you think it's immigrant friendly? No way. No way. I don't understand. What? But I get a bit of a clue that they want us to alternate fuel apart from biodiesel production. That's what I get. So really, okay, they are asking, hey, can you just name some sort of alternate fuel which is a renewable fuel which is produced using renewable renewable feedstock. Stupid. Can go get angry, man. Get angry. Anyhow, so I think that's what they are trying to say. Well, this then you can think about the bioethanol. Bioethanol. So for fermentation. Okay, that's the bioethanol. What are the renewable feedstock? You can say fermentation of what? Fermentation of glucose, made from fermentation of glucose. Right, fermentation of glucose. Then you can say glucose is produced by plant. What is this, man? Produced by plant. During photosynthesis. So then you can say renewable. Then why do we have to say renewable? Plants can be grown within a shorter period of time. Okay. Those plants, that's you have to say renewable, can be grown and replaced. Stupid. Replaced at a rate as fast as they are used. At a rate as fast as they are used. Oh God, what is this? As fast as they are used. So bioethanol, fermentation of glucose. Glucose is produced by plants due to photosynthesis. The plant can be grown and replaced at a rate as fast as they are used. And that's a good question. You should do this question over and over again, couple of times, 5 times, 10 times, until you get your head around this. Okay, don't expect you to understand. Some people can understand things straight away. I never used to understand things straight away. I had to do the same thing over and over again, over and over again. So you should do that. You should do that. If you don't understand this straight away, do it over and over again. Then you will get better at that. Now, what this question, H man, I could not understand what they were talking about. That's not immigrant friendly. No, no, no. Maybe. Oh, who knows? Who knows? Who knows? But anyhow, we did this. We did this. Now we got one more question to go. Okay. After that, we are done. We are done. Thank you. See you soon. Bye.